physics work with vectors? Well, if you take Mr. Hodgins' physics class in the future, he'll talk about forces. So, forces of 12 pounds and 16 pounds act at an angle of 90 degrees. Find the magnitude and resultant force of the that the angle makes with the first force. So if it doesn't tell you what direction it goes, you assume it's going at 0 degrees. So you have a vector going this way at 12 pounds of force, and you have a vector going this way at 16 pounds of force. Now, Mr. Hodgin will do it this way. He'll have you make head-to-tail vectors. This is a head. This is a tail. So he'll take this vector here and move it to over here. Your 16 pounds. So where the first one ends, the second one goes. And then this is your resultant vector. Okay? So we want to know what this magnitude is, and we want to know what this direction is. Okay? So magnitude. Well, you can basically do what you did before. This is, because this point is basically 12, 16, correct? So it's the square root of 12 squared plus 16 squared, or 144 plus 256, right? Square root of 400, which is 20. So it's a 20-pound force that's acting on the box. In which direction is it acting? Well, we take the inverse tangent of what over what? B over A, which is 16 over 12. Which is how many degrees? 53.1. Now, we're basically going into the first quadrant because we're going up and to the right. So do we have to change the angle at all? Add 180, subtract 180, or subtract it from 360? No. It's at an angle of 53.1 degrees. Okay? So that's a little bit of physics with vectors. Now for my most favoriteest trig problem of all times, the donkey problem. Two prospectors are pulling on ropes attached around the neck of a donkey that does not want to move. The donkey is being an asymptote here. He is not cooperating with those prospectors. One prospector is pulling with a force of 55 pounds, and the other one pulls with a force of 70 pounds. If the angle between the ropes is 30 degrees, then the prospectors are stupid, but also, as shown in the figure, then how much force must the donkey use in order to stay put? Okay? So he's pulling at 55 degrees that direction. He's pulling at 70 pounds in that direction. So how much force is the donkey pulling backwards? Well, again, when they pull together, their resultant force is somewhere out here. Where out there? Well, what happens is with these forces, we can make basically a parallelogram. Okay? And the reason why we use a parallelogram is parallelograms make really wonderful angles that we need to figure out. Because in a parallelogram, from geometry. And yeah, I expect you to remember a little bit of geometry. If this is a 30-degree angle, what's this angle up here in a parallelogram? 150 degrees. Because consecutive interior angles add up to 180 degrees. Okay, so this is a 150-degree angle here. Now, what do we know about opposite sides of a parallelogram? They're the same. They are congruent. So this is 70 pounds of force. All of a sudden, I have side, angle, side, and I want to know the opposite side of that triangle. So here's my resultant force from a force going that way and a force going that way. Okay, this is 150 degrees. This is 55, and this is 70. So what is this side? What method from early in the chapter would I use to find x? Do I have opposites? Law of cosines. So I'd have to use the law of cosines, where x squared would equal 55 squared plus 70 squared minus 2 times 55 times 70 times the cosine, not the sine, the cosine of 150 degrees. Can we put that straight into our calculator? Absolutely. So we put that straight into our calculator. After we get an answer, we take the square root of that, and we should get, probably about 121-ish, 118-ish, 115-ish, 120.8. Now, how did I know it was around 121-ish or somewhere like that? And that it wasn't like 60 or 70 or whatever. If we add these two together, they would add up to 125, right? Now, so if the prospectors had one rope and were pulling in a straight line, they'd be pulling with 125 pounds of force. But they went at an angle away from each other, lessening their force by 4.2 pounds. Okay? So the donkey is pulling back at a force of 128.8 pounds this way. For every force, there's an equal and opposite force. You learned that your freshman year in physical science class from Mr. Swenson. Okay? So that's why the donkey is staying put. This is classic physics. So if you're kind of into this kind of stuff, kind of neat problems, you kind of like this, take physics class as a senior. Okay? Because this is what it's like. Will, are you in physics class right now? Yeah. It's not anything like this, is it? Of course it's like this. First semester was like this. Yeah. Now you're into other stuff. A block of ice weighing 80 pounds rests on a 31-degree incline. So there's a block of ice here. Now, there's a lot of force of friction, so this doesn't slide down. Okay? So, that's the force of gravity. Gravity keeps us on Earth. Okay? That's the 80 pounds of force straight downward. Okay? It doesn't go parallel to the to the incline, it goes straight down because gravity pulls you straight down. So if I weigh 185 pounds when I step on the scale, it's gravity that's pulling me down with a force of 185 pounds of force. Okay? So that goes straight down. Now, there's a force going down this direction and a force going this direction. Okay? These are the two forces that act upon this to go 80 pounds straight down. Now, there's an equal and opposite force to this force that is called the force of friction. Okay, right, Will? The force of friction is going this way, while gravity goes straight down, which assists it going that way. Okay? So we need to figure out basically what the force of friction is to keep that block of ice from sliding down the ramp. Okay? So we need this force right here. Okay? Now, there's a 31-degree angle here. Which of these two angles is 31 degrees? This one up here or this one down here? The top or the bottom? The top is 31 degrees. Okay? So if that's 31 degrees and I have a right triangle, I want my opposite, and I see I have my, what's this side called of a right triangle? Hypotenuse. Opposite of hypotenuse is what trig function? Sine. The sine of my 31-degree angle equals x over 80. Now what do I do? Multiply by 80. What's 80 times the sine of 31? 41.2. That's the pounds of force necessary to keep the ice from sliding down. See, 41.2. The donkey, 120.8. And the other problems. Hey, we got them all right. Isn't that great? All right. So that is what you do to solve these. All right. So I will